It does not matter how slowly you go as long as you don't stop. Hi everyone. In this video, we'll go through problems related to partial fractions where we have to resolve improper fractions into partial fractions. You can join the Telegram group for any further updates and communications. You can also have mutual interactions with your batchmates within the group. The link to the Telegram group is given in the video description box. Here you have to resolve improper fractions into partial fractions. So all the problems from here on would be actually improper fractions which we have to resolve into partial fractions. Now if you look at this particular problem, the degree of numerator is the highest power. And what is the degree of numerator here? It is 2, because the highest power here is 2. Highest power of x is 2, so degree is 2. Similarly here, what is the degree in the denominator? Degree would be, when I multiply this x with this x, what's going to happen? It's going to become x square. So the highest power when I multiply these two factors would be 2. So for example, if I multiply 2 minus x with 1 plus x, I'll get 2 minus x plus x into 2, which is 2x, plus x into x, I'll get minus x square. So I'll get 2 minus 2 plus x minus x square. So now if you notice, the highest power here is 2. So degree is 2. So degree of numerator is equal to degree of denominator. Whenever the degree of numerator is greater than or equal to degree of denominator, then it is an improper fraction, right? So here the degree of numerator is same as degree of denominator. Both are 2. Therefore, this is an improper fraction. And therefore, before resolving into partial fractions, you will have to use the division method and get the quotient. We have to use the division method and get the quotient remainder. Let's use division method because it's an improper fraction. This is the divisor. This is the dividend, right? So we'll have to multiply these two terms. You cannot have two terms as divisor, right? So we'll multiply. When I multiply this, I'll get this particular expression. So let me rearrange. It should be in the ascending order. So I'll first put minus x square, then plus x, then plus 2. I need to rearrange the terms, right? You should start with bigger power, smaller power, and then only the number. Now we'll put this dividend. So remember, it should start from big to small. Big to small. When I say big, the biggest power should come in the first place, then second biggest, then just the number or constant. Now, how will I do the division? I'll have to take the first term here. And multiply with some number so that I get this first term. So I have to multiply minus x square with some number so that I get 4x square. So what should I multiply minus x square with to get 4x square? It should be into minus 4. Into minus 4, because minus 4 into minus x square is plus 4x square. Minus and minus becomes plus. So I need to multiply with minus 4. So minus 4. Now I have to multiply this minus 4 with this entire expression. Minus 4 into minus x square is 4x square. Minus 4 into x is minus 4x. Minus 4 into 2 is minus 8. Now we'll subtract the entire expression. So I get, this will get cancelled. So minus 3, this minus and minus will become plus. Minus 3x plus 4x would become plus x. And 5 minus and minus will become plus. 5 plus 8 would be plus 13. Now I can end this here because I have nothing to carry forward. And this remainder, whatever is left over here, is lesser than this particular first term. So x is lesser than x square. right? X is less than x square. Therefore, I need to stop it here. So now how I should write it as? I have to write this as quotient plus remainder divided by divisor or denominator. So what is a quotient? So notice this is the quotient, this is the remainder. This is the quotient, this is the remainder, and this is the divisor. So quotient is minus 4, remainder is x plus 13, and denominator or divisor is this much. I'll not write this denominator, I will write this original denominator, right? Original one, 2 minus x into 1 plus x. 2 minus x into 1 plus x. Now next step what I will do is, I'll have to find partial fractions for this. For this entire thing, I need to find the partial fraction. So x plus 13 by 2 minus x into 1 plus x. Now I have to resolve this into partial fractions. So what I should do? First I have to split. This entire thing into two parts, into two fractions. So I'll say it as, let it be a and b. I add these both. Now in the first fraction, I'll put first term 2 minus x. In the second fraction, I'll put 1 plus x. Right? Basically, I've splitted this entire fraction into two parts. Right? Each having one term in the denominator. So one fraction will have 2 minus x. The other fraction will have 1 plus x. Now I'll use LCM method. Right? Now what is LCM method? I will take both the denominators, all the denominators, like all these denominator terms, right? I'll find the LCM. Now you take this as the first, this as one term and this as one term. So I will take 2 minus x outside. 2 minus x will go once. 1 plus x, I'll leave it like that. Now I'll take 1 plus x. 1 plus x into 1 is 1 plus x, right? So now I stop it. The moment I get both the terms as 1, I stop this, right? So now this is my LCM. What is my LCM? LCM is 2 minus x into 1 plus x. Now what I will do? I'll put the LCM here. 2 minus x into 1 plus x. Now what I should do? Now to get this particular LCM, what should I multiply with this denominator to get this particular LCM? I have 2 minus x here. I should multiply with 1 plus x. If I multiply with 1 plus x, then I'll get this entire LCM, this entire expression. So I have to multiply with 1 plus x. But I'll multiply this numerator with 1 plus x. So it will be a into 1 plus x. A into 1 plus x. So it will be a into 1 plus x. Now next, I'll go to the second one. What should I multiply with this denominator term to get this LCM? 1 plus x is already there. So what should I multiply? 2 minus x. If I multiply this with 2 minus x, then I'll get this complete LCM. But I should multiply 2 minus x with numerator. Like this, b into 2 minus x. So I'll get b into 2 minus x. And this is equal to x plus 13 by 2 minus x by 1 plus x. Now denominators are same here, correct? So I can cancel this. Now I'll be left with this simplified expression like this. Now what I'll do? I need to find the values of a and b, right? I need to find the values of a and b. I will take the x values. X values, here you have 1 plus x, right? You have to equate this to 0. So it will become x is equal to, I'll shift 1 this side. So it will become minus 1. X becomes minus 1. Right? And here I have 2 minus x. So equated to 0. And then I'll find the value of x. X will become, I'll shift 2 this side. I'll get minus x. I'll shift 2 this side. So I'll get minus 2. I need only positive x. So what will happen? I'll shift minus here. Right? It will become plus 2. Because there's already minus here. So it will become plus 2. Or you can say minus and minus will get cancelled. Or you can also say minus if I shift here. It will become double minus. And double minus is nothing but plus. Minus and minus is plus. So x is equal to 2. So x is equal to 2. Now I'll substitute x values, right? And get values of a and b. So let's take x is equal to minus 1 first. So I'll substitute in this entire expression. Minus 1 plus 13 is equal to a into 1, what is x? Minus 1 plus b into 2 minus x is minus 1. So I'll get 13 minus 1 is 12. A into 0 plus 2 minus and minus is plus. 2 plus 1 is 3. 3b. Which means b is equal to 12 by 3. Which means b is equal to 4. So we got the value of b. Now let's substitute the next value of x. Substitute x is equal to 2. Let's put x is equal to 2. So it will be 2 plus 13. 2 plus 13 is equal to a into 1 plus x. X is 2. 1 plus 2 plus b into 2 minus x. X is 2. 2 minus 2 will get. So it will become 0. So 3a plus 0 is 15. A is equal to 15 by 3, which is 5. A is equal to 5. Now we got the values of b. We also got the values of a. We'll have to substitute it in this particular equation. We can call this as equation 1. Right? That is the splitted one. The first step what you do is split into fractions, right? You call this as equation 1. And this one where you have removed the denominators. Once you have removed the denominators, you call that as equation 2. Now let's substitute a and b in equation 1, right? Substitute a and b in equation 1. So what is equation 1? This is equation 1. So now I'll substitute a. A is 5. I'll get 5 by 2 minus x plus b is 4. 4 by 1 plus x. Now let's not forget to put the quotient. Right? Here we have to go to this particular equation. We can call this as equation 3 or whatever. Right? Right? We should not forget to put this quotient. So instead of this proper fraction, we'll put the partial fractions that we obtained just now and then add quotient to it. So it is going to be, I'll just put quotient to this. Quotient is minus 4. So this is the final answer. Let us go through a simple quiz now. An improper polynomial rational function is, choose the right answer. Option A, degree of numerator function less than degree of denominator function. Option B, degree of numerator function is greater than degree of denominator function. Option C, degree of numerator function is equal to degree of denominator function. Option D, both B and C. And then the second one is, in case of improper fractions, what is added to the partial fractions? Option A, remainder. Option B, quotient. Option C, divisor. Option D, none of the above. Choose the right answer and leave your answers in the comment section. Also, don't forget to press a like and share if you found this video useful. Now let's go to the next problem. Here again is an improper fraction. If you notice, the highest power is 3. So degree is 3 here. for numerator, and here highest power is 2. So degree is 2. Here if you notice, degree of numerator is 3 and degree of denominator is 2. Therefore, degree of numerator is greater than degree of denominator. Therefore, it's an improper fraction. So we'll have to use division method. We'll have to use division so that to convert improper to proper, right? Convert improper to proper. We get quotient, remainder and divisor. Using that, we'll have to convert into partial fractions. So in division method, this becomes a denominator divisor. So divisor is this much, right? Now I'll put the dividend, which is, now I have to multiply this first term with something. I have to multiply x square with something. So I get this first term, x cube. So obviously I should multiply x square with x. X square with x is x cube. So let me put x here. This is what I have to multiply. Now I'll take this x and multiply this entire divisor. X into x square is x cube. X into 5x is 5x square. X into 6 is 6x. Now I'll subtract the whole thing. This will get cancelled. 7x square minus 5x square is 2x square. 17x minus 6x is 11x plus 11x. I'll bring this 11 down, right? Now I have to continue this again. So again I have to look at the first term. First term is 2x square. Here the first term is x square. I should multiply x square with something so that I get this 2x square. So x square with 2 is 2x square, right? So I have to multiply with 2. So I have to add 2 here. I have to add 2 here. This 2 has to be added here. Now I'll take this 2 and multiply with this entire divisor. 2 into x square is 2x square. 2 into 5x is 10x. 2 into 6 is 12. Subtract the whole thing. This will get cancelled. 11x minus 10x is x. 11 minus 12 is minus 1. So this is the remainder, this is the quotient, and this is the divisor, right? Now we should write it in this form. What is the quotient? Quotient is x plus 2. What is the remainder? X minus 1. What is the divisor? X square plus 5x plus 6. Now we'll have to resolve this into partial fractions, right? Once we resolve this into partial fractions, we have to add those partial fractions with this quotient. So we'll first resolve this, and whatever partial fractions we get, we'll add with this particular quotient. Now, before we resolve into partial fraction, it has to be in the form of linear equation. In the form of linear equation, that is in the form of ax plus b, right? Like x plus 1 or x plus 2, like that. We can't have this quadratic equation, right? The power of x should always be 1. Power of x should always be 1. You can't have a power greater than 1. So we will have to factorize, right? We'll have to factorize this to get linear equations. So let me factorize this. Again, there are 3 methods to factorize. You can refer my video on factorization. 3 methods. Sum product, direct method of getting factors, and then we can use formula method, right? There are 3 methods. You can refer my video for each of these factorization methods. Here I'll use direct method because that's the simplest looking at this particular problem. So in the direct method, what I do, I'll have this one. So what I'll do is, I'll split this middle term into 2 terms. So I'll get x square plus, I'll split it into 2x plus 3x because 2x plus 3x is 5x plus 6. So I'll take common factor between these two. X is common. So I'll be left with x plus 2 plus here 3 is common. So 3 2s are 6. So x plus 2. Now again x plus 2 is common. So I'll take x plus 2 as common. Here I am left with x and here I am left with 3. So the factors are x plus 2 and x plus 3. So instead of this entire term, I can write it as x minus 1 by x plus 2 into x plus 3. Now I have to resolve this into partial fraction. So let's not forget, let's call this as equation 1, right? Let's call this as equation 1. Now we'll take this entire fraction here, this portion, and convert into partial fractions, right? So we'll get x minus 1 by x plus 2 by x plus 3. Now I split it into two fractions. Let's take first one, the numerator as a, second one numerator as b. I'll add both of them. Now what will be then the denominator? I'll take this first term, x plus 2. Then here second term I'll put it here, x plus 3. Order doesn't matter. I can even put x plus 3 here and x plus 2 here. It doesn't matter. So now I'll use the LCM method. LCM method is the simplest. It will avoid the number of steps. So what is LCM of x plus 2 into x plus 3? See, whenever you have two different terms, they are completely different. LCM would be just these two terms together, right? LCM would be, I'll first take x plus 2. X plus 2, it will go once. X plus 2 into 1 is x plus 2, correct? Now I'll copy x plus 3 as it is. Now I'll take x plus 3 here. X plus 3 into 1 is x plus 3, correct? X plus 3 into 1 is x plus 3. So now I have both ones. So I stop it here. So I'll take this. This becomes my LCM. My LCM is x plus 2 into x plus 3. See, you don't have to do all these steps. When you have two different terms here, you just take both the terms. That becomes the LCM, like this. You take both the terms and multiply them like this. This becomes the LCM. You don't have to do this step. This is only to explain. Now, what should I multiply with this denominator to get this LCM? I already have x plus 2. I don't have x plus 3. So if I multiply this with x plus 3, I'll get this LCM, correct? So I should not multiply x plus 3 here, but I should multiply x plus 3 with numerator. So x plus 3 into a. So I'll get a into x plus 3. Now, what should I multiply with this denominator so that I get this LCM? I have x plus 3 already, right? I have x plus 3 already. Now I need x plus 2, right? X plus 2. So I'll multiply with x plus 2, but I should multiply b. The numerator should be multiplied with x plus 2. So b into x plus 2. Now I'll write this, copy this as is. Now this and this will get cancelled. Same terms, right? It will get cancelled. So before that, let's call this as equation 2. I have splitted this partial fraction. I have splitted this fraction into two terms, right? Let's call this as equation 2. Once we get the final answer, once we find the value of a and b, we'll have to substitute in this equation 2. So now I'll rewrite this. Denominators have been eliminated. That is, denominators have been cancelled, right? Now I'll substitute the values of x to find the value of a and b. What will be the value of x? Simple. You have plus 3, it will become minus 3. Here you have plus 2, it will become minus 2. Right? Now I substitute both the x values one by one. First I'll substitute x is equal to minus 3. Again, order does not matter. You substitute either this value first or this value first. I'll take x is equal to minus 3. So when I take x is equal to minus 3, it will become minus 3 minus 1. Here it will be a into minus 3 plus 3. Here it will be b into minus 3 plus 2. I'm substituting x as minus 3 here. So I'll get a into 0. Minus 3 plus 2 is minus 1. So minus 1 into b is minus b. Minus 3 minus 1 is minus 4. So b is equal to 4. Here minus and minus will get cancelled. So b is equal to 4. Now let's substitute x is equal to minus 2. This one. X is equal to minus 2. Minus 2 minus 1. Everywhere wherever x is there, I'll put minus 2. So I'll get minus 2 minus 1 is equal to a into x plus 3. So minus 2 plus 3 plus b into x plus 2. So minus 2 plus 2. So this will become 0. This will become 3 minus 2 is 1a. And this will be minus 3. So therefore a is equal to minus 3. Right? We got value of a, we got value of b. Now we have to go to the equation, this equation. Right? Where we split it into fractions. Take this equation, put the value of a and b. So a is minus 3 and b is 4. What are the denominators for a? X plus 2 and x plus 3. So it will be x plus 2 and x plus 3. So these are the partial fractions. Now what is the last step? We have to put the quotient. Let's not forget the quotient. What was the quotient that we got? We'll have to add the quotient. Quotient is x plus 2. So we'll just put x plus 2 here. So this is the final answer. Now let's go to the next problem. Here again, if you look at the degree of numerator and degree of denominator, the highest power is 2 here. Here also highest power is 2, which means this is degree. Right? Degree of numerator is same as degree of denominator. Therefore, this is improper fraction. Now we'll have to use division method to find the quotient remainder. Right? We'll have to use division method. Right? So we'll have to put the divisor. This is the divisor. I put the divisor here and I put the dividend. Now I'll need to find the quotient. So first observe this first term and this first term. Right? What should I multiply x square with to get 2x square? I should multiply with 2, obviously, right? If I multiply x square with 2, I'll get 2x square. So I'll put 2 here. Now I'll take this 2 and multiply with this entire divisor. 2 into x square is 2x square. 2 into minus x is minus 2x. 2 into minus 2 is minus 4. Now let me subtract the whole thing. So this will get cancelled. Minus and minus becomes plus. So 3x plus 2x is 5x. 2 here minus and minus becomes plus. So 2 plus 4 is 6. Is there anything to carry forward? No, there's nothing to carry forward. And also you have to observe the denominator. Here x is smaller than x square. Whenever the remainder is smaller than the divisor, you have to stop. Here x is smaller than x square. Right? So this is the remainder. This is the quotient 2 and this is the divisor. So we have to write it in this form. Quotient plus remainder by divisor. What is quotient? 2. What is remainder? 5x plus 6. What is divisor? This one. X square minus x minus 2. Right? Now let's call this as equation 1. Now we'll have to resolve this entire thing into partial fractions, right? Once we resolve this into partial fractions, you add this quotient to that partial fractions and you get the final answer. So now, before I resolve this into partial fraction, if you notice, the denominator is a quadratic equation, right? This is a quadratic equation, right? I have to convert it into linear equation. How do I do that? I have to factorize, right? I need to factorize so that I get in the form of linear equation, that is in the form of ax plus b, right? Now how should I factorize this? X square minus x minus 2. I need to factorize this. Again, you can watch my video on how to factorize. There are 3 methods like I said in the earlier problem. You can use either formula, direct or sum product. In the earlier problem we used direct. Here we'll use sum product. In sum product, you take 2 numbers, number 1, number 2. I have x square minus x minus 2. When I multiply, I should get this number. When I add, I should get this number, right? Multiply, I should get minus 2. When I add, I should get minus 1. I mean, just take the coefficient, not x. Just the coefficient. Coefficient of x is, there's nothing here, so it's 1. And there is minus here, so minus 1. So, when I multiply, I should get minus 2. When I add, I should get minus 1. So, obviously, if I have to multiply, I have to get minus 2 means minus 2 into 1. When I multiply minus 2 with 1, I get minus 2. 1 I should guess. Basically, I have to guess these numbers. And when I add, I should get minus 1. So, when I add minus 2 and 1, I'll get minus 1. So, the numbers satisfy both the conditions, right? Minus 2 and 1. Minus 2 and 1 are the numbers. If you notice, if you multiply minus 2 with 1, I'll get minus 2. If I add minus 2 with 1, I get minus 1. Right? That is what I need. So we got the numbers as minus 2 and plus 1. So in sum product method, how we should write the factors is, we write at x, whatever number we've got, just put it as like this, x minus 2. And you've got 1, so we'll put x plus 1. This is how we have to write the factors in sum product method. Right? X minus 2 and x plus 1 are the factors. So now we have to write this original fraction into this way. We'll have to put the factors here. So factors are x minus 2 and x plus 1. Now we'll resolve this into partial fractions. So we have to split. How many denominator terms we have? 2. So we'll have to have 2 numerators, a and b. Add both of them. We have 2 denominator terms, so we'll have 2 fractions, right? This is one fraction and this is one fraction. We'll put one denominator here and the other denominator here. Order doesn't matter. You can put x minus 2 here or here, anywhere, doesn't matter. So these are the splitted fractions. Now I have to find the value of a and b. That's when I will get the partial fraction. So now I'll use the LCM method, right? Simple. Both these denominator terms are different, right? So just multiply, that becomes the LCM. So it will be multiply both x minus 2 and x plus 1. Now what should I multiply with a to get this LCM? So I already have x minus 2 here. What is left out? X plus 1. So I should multiply a with x plus 1. Only then I will get this LCM. If I multiply x minus 2 with x plus 1, I'll get this LCM. So I have to multiply this x plus 1 with numerator. So a into x plus 1 plus b into, now I already have this x plus 1 here, right? What is left out here? X minus 2. So to multiply this with x minus 2. But I have to multiply b, the numerator, right? So b into x minus 2. Now I'll copy this left hand side as is. The denominators will get cancelled because both are same, right? Now I'll get an expression which is free of denominators, which doesn't have denominators. So now I'll find the values of x. What is the values of x? Simple. It's plus 1, so it becomes minus 1. Here it's minus 2, so it becomes plus 2. Now I have to substitute each of these x values and find a and b, right? Now we'll substitute x is equal to minus 1. So I'll get, so it's 5x. So 5 into minus 1 plus 6 is equal to a into, instead of x I put minus 1 plus 1 plus b into minus 1 minus 2. Notice one of the terms will become 0 here, right? So minus 2 minus 1 is minus 3b. Minus 5 plus 6 is 1. Therefore b is equal to 1 by 3, minus 1 by 3, right? Now I'll substitute x is equal to, what is the next value? 2. I'll substitute x is equal to 2. So I'll get 5 into 2 plus 6 is equal to a into x plus 1. X is 2. So 2 plus 1. This b will become 0. One of the terms has to become 0. So this will become 2 minus 2, which is 0. So you get 3a plus 0 is equal to 16. Therefore a is 16 by 3. So I got both a values and b values. Now let's substitute in this particular partial fraction. So what is a? A by x minus 2. So I'll get 16 by 3. What is b? B is minus. So minus 1 by 3. What was a? A by x minus 2. B is x plus 1. X plus 1. So this is the partial fraction. Now let's not forget to add the quotient. What is the quotient? Remember, this is an improper fraction, right? What is the quotient? The quotient we got is 2. So let's just put 2 here. Let's add 2 here. So this is the final answer. Now let's look at this particular problem. Again, this is an improper fraction, right? The highest power is 3. Here, if I multiply x with x, I'll get 2x cube. So highest power is 3. Here also it's 3. So it's an improper fraction because degree of numerator is equal to degree of denominator. This is degree of numerator. This is degree of denominator. Now I'll use division method. So in the division, I can't add 3 terms as divisor. I have to multiply. Only then I can put as divisor. So I'll have to multiply this entire thing. So it will be, first let me multiply these two. So it will be x square minus x. Then multiply with this 2x plus 3. So I'll get 2x into x square is 2x cube. 2x into minus x is 2x square. Now I'll take 3. 3 into x square is 3x square. 3 into minus x is minus 3x. Now I'll add this. 3x square minus 2x square is plus x square minus 3x. So this is the divisor. Now let's put the divisor. 2x cube plus x square minus 3x. This denominator becomes the divisor. And dividend is 2x cube plus x square minus x minus 3. Now I have to find the quotient. So take the first term here. This is the first term, right? So I should multiply 2x cube with something to get this first term. To get 2x cube. What should be 1, right? 2x cube into 1 is 2x cube. So 1. So I multiply this 1 with this entire divisor. So 1 into, it will be the same thing, right? 1 into 2x cube plus 1 into x square, 1 into minus 3x. Be minus 3x. Now I'll subtract the whole thing. This will get cancelled. This also will get cancelled. Minus x, minus and minus will become plus. Plus 3x minus x. So it will be 2x. And I'll carry forward this minus 3. See here, I have carried forward it. But here if you notice, the remainder is small. This x is smaller than x cube. X is smaller than x cube. So I have to stop it here. Right? Whenever the remainder is lesser than divisor, I need to stop it. Here remainder is 2x and here the first term is 2x cube. So obviously this is small, right? So I have to stop it here. So now I have to write it in this form. What is quotient? This is quotient. This is remainder. So now instead of quotient I put 1. Instead of remainder I put this 2x minus 3. Instead of divisor I put the original divisor, which is this one. Right? Now I will find partial fractions for this. I find partial fractions for this and then add it with this quotient. So let me write this. Now I have 3 denominator terms. So I have to have 3 fractions, A, B and C. 3 fractions. Because I have 3 denominator terms, x, then x minus 1, then 2x plus 3. Now I have to use LCM method, right, and get the LCM. Now all 3 are different, is it not? All 3 are different. So LCM will be straightforward. Multiply all the denominators, that will become the LCM. Right? See, even if I use this LCM method like this, x minus 1, 2x plus 3 as LCM, I'll first take x. X into 1 is 1. Rest I'll copy as it is. Next I'll take x minus 1. Right? X minus 1 into 1 is x minus 1. I'll copy 2x plus 3 as it is. Now I'll take 2x plus 3. 1, 1. 2x plus 3 into 1 is 2x plus 3. So I'll multiply all this. This will become the LCM. Now, what should I multiply with A to get this LCM? Right? I already have x here. Right? What are the remaining terms? X minus 1 and 2x plus 3. If I multiply the remaining terms with this x, I'll get this entire LCM. Right? So I need to multiply with x minus 1 and 2x plus 3. Right? So let x minus 1 into 2x plus 3. Now I'll go to second one, B. Here I already have x minus 1. So what are the 2 terms left? X and 2x plus 3. Right? So I have to multiply this with x and 2x plus 3. X into 2x plus 3. Now I'll go to next one, C. Here I have 2x plus 3 already. So what are the terms left over? X into x minus 1. I have to multiply C with x and x minus 1. So I'll copy this as is. So this denominator will get cancelled. So I'll be left with this entire expression. Now I have to find the value of a, b and c. So I have to get the values of x here, right? So simple. Here you have minus 1, so you put it as 1. Here what will be x? So what you have to do is, you have to equate 2x plus 3 equal to 0. So I need to find the value of x. X will be, I'll shift 3 here, so it will become minus 3. Now I'll shift 2 here, so it will be minus 3 by 2. So x is equal to minus 3 by 2. And next value of x would be, here I have simply x. When you have simply x, it means 0. X is equal to 0, right? Right? Because ultimately you're going to equate all of this to 0, right? X minus 1 equal to 0, which means x is equal to 1. Here 2x plus 3 equal to 0. Then you will take x is equal to 0. That's how you get these values of x. Now I'll substitute x is equal to 1. So I'll get 2 into 1 minus 3 is equal to, so when I put 1 here, it will be 1 minus 1 and it will become 0. Here I'll put b into x as 1, 2 into x plus 3. And c, x is 1 and 1 minus 1. So this will become 0, 5b, and this will become 0. This will become minus 1, which means b is equal to minus 1 by 5. Now let's find the value of a. So I'll substitute x as minus 3 by 2. X as minus 3 by 2. So 2 into minus 3 by 2 minus 3. A into x is minus 3 by 2 minus 1 into 2. Instead of x, I am putting minus 3 by 2. It will become 0 here ultimately here. Plus b into minus 3 by 2. Again, it will become 0 here. So it will become 0 plus c into minus 3 by 2 minus 3 by 2 minus 1. See here it will become 0. So if you got the x value from here itself as minus 3 by 2, when you substitute minus 3 by 2 here, it will become 0. See, 2x plus 3, when I substitute x as minus 3 by 2 plus 3, 2 and 2 will get cancelled. So I'll get minus 3 plus 3, which is 0, right? So basically this will become 0. This one also will become 0. I'll only have c value, which is minus 3 by 2 minus 1 would be, I'll take LCM as 2. So it will be minus 3. I have to multiply this denominator 1 with 2 to get this LCM. So I multiply numerator. Minus 1 into 2 is minus 2. Get minus 5 by 2. So I'll get minus 5 by 2. So I'll get 15 by 4 is equal to, here 2 and 2 will get cancelled. Minus 3, I'll get minus 6. So c is equal to minus 6. I'll shift this here. When I shift 15 by 4 here, it will become reciprocal. It will become 4 by 15. So this will be minus 8 by 5. C is minus 8 by 5. Right? Now we have another value of x. We finished this. Now x is equal to 0 we'll have to put. So I'll put x is equal to 0 here. It will become minus 3. A into 0 minus 1. 3 plus, this will become 0 entire thing. Here also it will become 0. So I'll get minus 3a is minus 3, which means a is equal to 1. Let's go to the splitted one, this one, and let's substitute a, b, c values. 1 by x, what is b? Minus 1 by 5, copy the denominator, and c is minus 8 by 5, minus 8 by 5 into denominator. Now let's not forget the quotient. We had got the quotient. What was the quotient? 1 was the quotient. So we put 1 here. So this is the final answer. So with this, we've come to the end of this particular video. If you like this video, do press a like and share it. Thank you.